Okay, today we are going to talk about the procedure called creating file systems in Linux. There are some steps like uh, previously we discussed if I have a disk, the physical disk, that disk we can create a PV from that disk. Like from the we have to create a PV. Keep in mind the sequence. Create a PV, that is called physical volume PV. Create a PV from the disk. The disk means hard drive. Okay, create a PV from the hard drive, and from the PV create a VG, that is volume group. Means the first PV, then volume group. Once we have the group like the volume group, you can create a LV from that volume group. LV means logical volume. So first let me type in here. First we have to create a PV, then we have to create a VG. The PV is created from what? uh, Physical hard drive. VG is created from the PV. Then after that we are going to create a LV from the VG. LV is like a one slice of that complete VG. Okay, VG means volume group. The group name itself indicates it's a like big something, it consists of something that is called a group. uh, and from that group we are creating a LV, logical volume. The logical volume is like a small piece of that VG. Okay, and once we have the LV or logical volume, we can create a file system on that LV or logical volume. Okay, uh, and once that file system is created, how we can create a file system from the LV mkfs command. So okay, and then we can add mount that file system, mount that we can say, like, let me say file system fs. So this is my sequence. First create a PV from the given hard drive, and then create a VG from that PV, and then the LV from the VG, and getting LV or creating LV is the most important thing. And once we have that volume, or we can say logical volume, then we can create a file system. MK means make file system from the LV, and then mount that file system. Okay, so let me uh, uh, let us see whether we have the disk. So for the disk, like, let's go to some directive, for example. Okay, so f disk dash L, it shows what are the disk I have on my machine. So this is the one disk, its size is 80 gig. So this disk, and its disk name is /dev/sda. And from that disk there are other partitions created, like sda1, that is first partition, and sda2, that is second partition. So for example, if I want to display what are my partitions in my disk, so you can say f disk dash L, means L means list, and paste that. So the /dev/sda, and I'm sorry, f disk. So you can, okay, so this is the command I'm using, fdisk dash L, and the name of the disk, that is /dev/sda, to display what are the partitions. Okay, so we have already uh, this partitions created. You can create a PV from the uh, partition, and that partition may be like a small partition or the one big partition of the complete hard drive. Okay, so the and we have and to display with the PVs are already created. You can use a like a PV command and just put in S. That is, I think, alias for something PV display or something. So PVS, if you put in, so it will display uh, this this will display the okay. So if I say like PVS means PVS means like a display what are my PVs are available. So this PVS command displays. So this is show like this is PV, is a heading PV, and its name is this one. Okay, and that PV uh, was added in VG, and that VG name is this one. Okay, so 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 for creating a PV, so the if you go to the our previous uh, our previous steps, so the sequence is like a create a PV first. So right now we are going to use this PV itself, the which one is already created. Okay, and the VG, this was also created. But if you want to use like command to create a PV, so you can say like PV create. Okay, and give the complete name of that partition. So slash dev slash sda, for example, like a partition number 5. So you can create a slash dev slash sda 5 PV, and then it will display uh, uh, when you are running the previous command, it will display that PV name. So this PV we are not creating because we already have that PV. Similarly, VG also you can create like a VG create command, like VG. Okay, VG create and give the name of the uh, uh, volume group name, and that we can say like I can say VG like 100 something any name, like for example here the VG name is something this one. You can give any name whatever you like. VG create and give the name of the VG. VG means like volume group. Okay, VG create uh, and you can you cannot create a VG which doesn't have any PVs, so you have to mention the PVs. uh, so you can use any PV the one you created, like slash dev slash sda 5. For example, you created sda 5 PV. So now in this case you are creating a VG from the PV. Okay, and your that VG's name is this one. Okay, but I'm running this control C because I'm not creating that, I'm terminating them, because we are going to use this VG itself. Okay, now so now we have the PV created, we have the VG created. You understood, right? Even though the um, PV we didn't create, but we are using the previous one, the we which already exist. Okay, and also we are going to use this VG. Now the third step is to create what? LV, logical volume. So to create a logical volume, for example, what are the logical volumes available? These are to see what are the logical volumes available. These are the names of LVs. So you can see this is one LV, another LV, this LV, this, right? All these are the LVs. So uh, you can create a like let's create one LV. So you can say create LV create, and then give the uh, give the name to the LV. You can say something whatever, like a my data, my data LV. You can give any name whatever you like, but if you put in something LV in name in that, then it is meaningful to understand to others. So I'm giving a LV create, give the dash n means name, and what is the name, this name I'm giving. Okay, then what is next? What is the size of that, your volume? So that size I'm putting in a capital L. And for example, I want to create a uh, like a 2 gig 2 GB's size logical volume. This logical volume is just like our C drive and D drive in Windows. Okay, so this is this my data LV is basically C drive, for example, in Windows language. So LV create this one, and this dash L and the size, and this LV where we are creating in one VG. Okay, VG means like we made one group before, right? And from that VG we are creating uh, so many LVs, like one my data LV, my Apache LV, and so many home LV, or so many volumes we are creating. So but here we are creating one volume, our logical volume, and that is my data LV, and size is 2 gig. And we are creating from which VG, we are taking the existing VG. So this is the VG, the heading, and this is the VG name. So let us take this VG and put in here. Okay, and that's all, and just hit enter, and she's showing the yeah, and it is showing this LV, this my data LV is created, and that is successful. And where we can check that, so you can check in you can check that slash dev slash in your VG it was, right? And then what is the name of your uh, LV in this one? So you can see that this is created. Okay, and this once the LVL volume is created, that is the main task you achieved. So after that you can just create a file system on that volume. you know um, how we can create a file system? We can say make file system, sorry, mkfs, right? Then T, and what kind of file system you want, ext3 ext4 file system. Okay, and give the complete path of that your volume or logical volume. We usually say only volume because volume is the main name in there. So logical, that is also there, but right now most important is volume. Okay, so we are creating a file system on the volume, uh, this on my LV. Okay, so say make file system, and it is creating a file system or making a file system, and it made the file system. So it's showing something it created, it's done, it's showing it's done, file system is created. Now you have to just add that file system, like you can say, like you can not add, you can say mount, and use it, you wanted that file system at for like my data. So you can create any mount point, you can mount anywhere. So if you like make one directory like folder, like my data, you can give any name. Okay, and then mount what type of file system is this, ext4, and this here is the file system. Okay, and where it is, where you are mounting in this mount point. So you understood now, you are mounting your file system, that file system is created from that volume. Okay, you are mounting that file system, okay, at this mount point. Okay, and then hit enter, and it's mounted. Now how you can see that whether it's mounted or not? You can see df minus k or df dash h, and see it's mounted. Now this file system is ready for use for all users. It's like a home. It's like you can do whatever you like in this file system. You can go over there, you can create your files, create your files, programs, something, and then see, this by default is some small file to check if there are any errors or something. But you can say like a create any file, like creating one file like a touch my my program .txt. Okay, this is my program, so this file is created. Okay, so I can say vi my c1 program, c100 program, like vi, then I'm writing something there, and something my my commands or something, right, I'm writing in there, and that is my file. And this is the way we have created the file system. And but if you reboot this server, this file system will not be mounted automatically when the machine is coming up next time. So in order to get that mounted automatically every time, every day, whenever you are rebooting the server, you have to add this entry in one file that is called fs tab, that is in hc directory. So if you decide like fs tab, so this is the fs tab. Okay, so you can do one thing. This is your volume. That volume contains a file structure. Now it's not like a raw volume. It was a raw volume, right? You can see this little bit name is changed here. Okay, this name, but that is again is a link. I'll explain that later. If you see like L, that is pointing to this DM4. Okay, or this is also actually if you say slash there, what is the name of my wall VG? This is the name of my VG, and underneath VG there was my LV, right? This was actually the name of the full path of that volume, right? So we do this, both are pointing to this one. This path and this mapper path, both are same, because those are pointed to the same this DM. That I'll explain later on. But right now our main point is to get this file system mounted every time. We have to add this entry into the fs tab. So you can add any entry, like for example this one. Let's go to VIFS. Let's take a backup of backup means like take a copy of our existing I can say old, and now I'm modifying the original file, and in here I'm putting this volume, the complete path of our file system or volume name, right? And then where we want that my data, right? And the remaining fields I'm just copying and pasting here. It's a ext4 file system, and it's all the mounts are defaults, mount options are defaults, and this everything same, and just copying and pasting. So I am more interested in this one. What is the name of my volume, and where I am mounting it. Okay, the remaining field I know that it's a ext4 file system, because when we created we mentioned that it's a ext4 file system, and those are most important. Okay, the file system we have mounted here using what command, uh, that mount command, right here, right, that we have given this mount command, and what is to be mounted and where to be mounted. Okay, so what is to be mounted is my this volume which contains the file system structure, and here is the mount point. Okay, now we have added this entry, this volume and its mount point we have added into fs tab. Now if you unmount that as my data, the one we had mounted, if you unmount, right now it's not mounted because we unmounted it. See, you can see that it's not it's not a separate file system, it's just a simple directory of the root file system. This is a root, slash means root, you know that a root, right? What are other file systems mounted? Like the other file systems are different mounted, like that's VM data, slash home, slash boot. These are the file systems mounted. Okay, but the file system we created is unmounted now. Okay, now we have added that entry in etc fs tab, right? And now if you want to mount it, you can just mount and give the name of the, we don't have to mention everything now, like what is the uh, type of the file system, that the dash text4. We don't have to mention what is the volume name, because that is we have already mentioned in fs tab. When we are running this command, when you are executing this command, at that time this system, this linux machine, or this computer kernel will go to the fs tab and take that entry. It knows what volume to be mounted on this mount point, because we have mentioned there. So if we just like say mount and mount this file system, that's all, and it's mounted. Because whereas here we had to provide all parameters, what to mount and what kind of file system and everything, everything. But as we have mentioned in we like a cat cfs tab and grep what, my data, right? My data was the, and this everything is mentioned in fs tab for our newly created file system. That's why the system is directly going to the fs tab and taking all the information from there and just mounting it. Now this is most important, because you have to deal daily uh, with such kind of scenarios, like you have to create the file system uh, again to revise all these steps. And you can see like what are the commands you executed, like you can say like history, you can see all the commands of whatever you executed, you can see here all the commands. Okay, so basically what you did, we wanted like a first PV, but PV we used the existing one. We wanted VG, that volume group, we used the existing volume group, that's something like this. Okay, then we started creating LV, that is volume manager, and no, not volume manager, volume, logical volume. Okay, so once we have the LV, you can use the short forms, like use like a PV, VG, and LV in day-to-day communication. So once we create a LV, we create we made a file system on that, and that just mounted that file system on a specific mount point here, and that's all. And fstab entry also, why fstab entry here, because the next time when you are rebooting the server, it will be this file system will be mounted automatically. So this file system is basically for any this space, like it's like a C or D drive for uh, for installing programs, creating files and your data. And now no matter how big is your data and what kind of data is that, it will be stored in there. Okay, so creating a file system uh, or the extending the file system is very important task in system administration, especially the logical volume manager. This is called LVM. So if we say ps minus ef grep LVM, you can see something LVM related, or you can check the service. How to check the service. You can say chk config-l list in grep. You can note down this command, grep LVM. So LVM means logical volume manager. That is the one software. This complete software maintains this all kind of small pieces like PVs, PVGs, LVs, file systems, and everything. That's the reason why it's called software. There are so many software available in the market. So for the LVM. So this LVM, right now these are the run levels like 0, 1, 2. We will discuss those run levels, but that LVM software is up and running. So it's showing on for this run levels 1, 2, 3, 4, 5. It's on. Okay, so now we understood how to create a file system. Okay, that is, we can say, one kind of we can say lesson. Okay, creating a file system from the logical volumes, or using a logical volume, or using LVM. Okay, now I'm taking a small break of like 30 seconds. Okay, now that is one step is create one lesson done. Now let us move to how to expand, how to make that bigger, the that volume of the file system, how to expand the file system. Like if I like what is the size right now? Right now it is showing size is 1.9 gig. Okay, it was 2 gig, 1.9 gig, right? 4% is already utilized for some other system purpose, but 1.9 approximately 2 gig size. Okay, so 2 gig size, if I want to expand it, like in day-to-day life, there are like so many requirements, to put in a big data into the file system. So this file system will become 100% full in like 1 or 2 months. So we have to expand it. To expand it, uh, we have to use some like a lv extend command, and then that is like a two steps task. One is a lv extend, means extend the volume, extend the lv, then run the resize e2fs. The two command like a lv extend. So means we are extending this lv. This is the complete our LV's path. Okay, and we are extending that and then running which command that is called resize, like a resize e2fs. Okay, that command. Okay, but let me control C this first. So let's say extend this. Ours is like a 2 gig. Let's make it like a 4 gig, 4 gigabyte GB. Okay, 4 GB. So for GB I'm saying a gigabyte, right? So we can say okay, LV extend. We are extending to 4 gig. Okay, from the 2 gig. Okay, LV extend, LV extend, and give the, the final size of your volume. So I'm saying a 4 gig. Okay, and what you are going to extend, so give this complete your LV's path. Okay, and just say run, and successfully resized. See, this is our LV. So this is our LV, and its complete path is this one. If you are not giving complete path, you have to mention somewhere that like this is my VG. It should be under VG. This one. So you are giving the complete path, so system knows. Okay, this is the your complete path, path of your LV. Okay, so now this is extended, but the only volume is extended. You remember we had created a file system on that mkfs. So that file system structure needs to be extended along with this LV. So that command is the resize e2fs. Okay, and give the name of your that LV, that volume. Okay, and then it's performing that, and it is done. It is showing is now this long. So this is done. It's resizing is done. So now if you see, it was a 2 gig before, 2 gigabyte, and now if you can see how much it is that, and you can see it is 4 gig now. Okay, so this total size, and this is available is showing. So it's almost like a 4 gig. Okay, 2% utilize. So now you know how we extended the file system. So extending the file system, okay, this file system actually size, extending file system size is regular work in Unix administration. Okay, so you should keep in mind these two commands, like the LV extend. Okay, and then after LV extend, run this resize e2fs. This e2fs actually, this name resize, we can understand what is the meaning of resize. Means like whatever the size we have, that resize it, make it like a smaller or bigger as per the volume size. Okay, that is a resize. Okay, that e2fs is basically, I think, came from the ext2 file system. Right now these file systems are like ext4. See, we say like my data, right? You can see what is this file system time. So right, these are extended file system 4, right? So this command, I think, came years ago from the ext2 file system. That's the reason. But we don't have to worry where it came from. So this is the command resize e2fs. It changes the file structure to meet this size, to meet the volume manager size. Okay, so this is the another we can say part of that lesson, like in file systems. So extending file system is a regular task that you have to work on. Okay, now there are like there is a called a swap concept. Well, if you want to remove that, you know, remove that volume manager, no, volume LV, then you can say LV remove. You can see that the commands how they are starting. Like if you want to create something, then you can say LV create. If you want to remove something, then you can say LV remove. Something means volume manager. So if you want to remove the volume, so you can say LV remove. Okay. If you want to uh, extend, then you can say LV extend. Correct. You can see the you have to just put in LV with the LV PV. Similarly, like a PV create, PV remove, some similar command. VG create, VG remove. These are the commands. Okay. So LV extend. So you can see like create, remove, extend. These are the common commands you have to use. If you want to remove, so say LV remove. Okay, so LV remove, and what way I'm going to remove? I'm going to remove this mounted file system. Okay, but it may not allow because this file system is mounted at this mount point, mounted on this mount point. So it may not allow. So what you have to do is you have to unmount it and then remove. Okay, so let us try before unmounting. So LV remove this, and then see, you can say file system in use. You cannot remove it because other people, other users or programs or someone are using that file system. So you have to say umount. Unmounts short is umount. Umount what? This is my file. This my data is actually file system now, even though it's a mount point, because this contains this file system, right? It contains the file system and it is mounted at this point. So my data is called a file system actually, but internally this is the file system. But it's a so my data is the file system. I'm unmounting that file system, unmounted. Now if you hit that up, this this arrow, upper arrow on the right or lower corner of your keyboard, right? uh, that is called DOS key. Okay, then you can remove that. Let's remove now, LV remove, and now and it's asking, do you want to really remove it? You can say yes, I want to remove it. So just put in S and removed, successfully removed. Okay, and now if you say like a mount, after after removing, if you try to mount it, right, the way you had mounted before, it will show no, it doesn't exist, somebody already removed it. Okay, so if this doesn't exist, this no longer exists, if it already removed, you have to take out from the FS tab also. Otherwise, when we reboot the server, it will try to find out that where is this LV. So let's uh, remove that. This no longer exists. So remove this entry. DD removed. Okay. So we had created a file system uh, and we removed it. Okay. Now we can create a swap space. So that was this, this is like a two things we have completed so far. One is creating a file system from the uh, you know using a logical volume manager software, that is LVM, right? So whatever the commands we are using, those are from the LVM, logical volume manager. So we created a file system from the uh, by using LVM software, right? That is first thing we did. The second what we did, we 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 learned how to expand the file system. That is second. I'm writing here two. We learned that. That is second thing we learned, extending the file system. Okay. Now what we are going to learn is how to create. I'm just writing here for your understanding. How to create a swap. What is swap? What is swap? Swap is, now this is the third we can say part or lesson. Okay. Swap is basically a, a, reserved area in a disk, like it's one part of the or partition of the disk which is used as a secondary memory. Like we have like if it's like how much memory I have on my machine. I have like a 4 gig of memory RAM, or 2 gig of RAM, right? So that RAM or memory sometimes is not enough if there is a big huge load on the machine. So this machine or this operating system, what it does, it it moves some contents from the memory, from that 2 GB memory, okay, to the some reserved area on the disk. And and uh, and the which contains some program which are idle. Some users data, or something some programs or processes which are idle. Those are not doing anything for a long time. It moves, system moves. System is like operating system. Okay. The operating system moves those idle processes or programs to the reserved area, and that reserved area we are going to create. That is called swap. So and that we are going to create from using a LVM software. And for that we have to just create one volume, the logical volume LV we created. So just create the LV. Okay, create that LV. Like for example, if you have like a 2 gig of memory on your machine, right? and you can uh, and you can create like a 4 gig of one LV, and that LV or reserved area on the disk will act as memory again. It's like a primary memory and secondary memory. So and this primary memory, this RAM, is very expensive in market. So that's why you can and the disk are like less expensive. Like you have like 80 gig disk, 120 gig disk, 500 gig disk, right? So you can use those disk for memory purpose. So let's create LV. Let's create one volume, and from that volume we'll create a swap, and that swap will be the secondary memory. Okay. So LV create dash L dash L. I'm going to create a like a one like a I have already 2 gig of memory on my machine. So I'm going to create a same amount of memory, same amount of one partition for the memory purpose. So means I have like a 2 gig right now, and I'm going to create another 2 gigs. Then it's like as good as I have like 4 gig of memory on my machine. So LV create dash L 2G. 2G means like a size of uh, size of that partition 2G. And what is this name? I can give some name, like I can say like a swap 2, or we can say swap LV. I can say like a swap 2 LV, so that it will be something meaningful, because possibly we already have the swap. Let me terminate this first. Let's check whether swap is there. Swap on dash L or S. Okay, it shows some kind of swap is there, and its size is 4 gig. See, you can see this is in kilobytes, right? So this many k, so 3 digits like 1000, right? And this many MBs, 4014 MBs, right? And 4 gig. See, 4 gig, this is already there. 4 gig swap is already there. Somebody already created 4 gig of swap on this machine. So means like 2 gig the real memory plus 4 gig this is swap or secondary memory, and we are going to create an additional one 2 gig, or let's say 1 gig, 1 gig swap, and I'm giving something some different name now, this one. Okay, and we have to mention the VG name here. So VG name, we can say like, let me control C this, terminate this first. So VG name we can say like VG, and S you can put in like LVS, PVS, VGS, right? So this to display, and you can see the VG name in our system, our machine is this one. Okay, so I'm going to create a one LV, its name is this. I'm using that for swap purpose, that's the reason I give some meaningful name, but you can give whatever you name you like. Swap to LV, so meaning that this is LV, this is a logical volume, it's not something different. So that's the reason I put in a LV name in this, so that in future also I can understand from the name itself this is LV. And where is the VG? And VG is this one. I have to mention VG, where I'm creating this my LV, in which group, and this is the name of that volume group. Volume group is the big one. Okay, and inside there are like so many LVs, small LVs. The small LVs you can display by LVS command. So now what you are doing, you are creating again same thing like the way you created the LV for creating a file system. Similarly you are creating a LV for this swap. Okay, and hit enter, and it created. Okay, so this step is same. When you created the file system, you created the LV first. So creating LV is the main center point of everything, all your task, creating LV. Okay, now you can create a file system on that, or you can create a swap on that. So file system we are already created last time, MKFS. Now we are creating a swap structure. So swap structure you have to use like MK swap command. So you can MK swap and give the complete name where you are creating the swap. I'm making MK means make swap. Make swap on what? You give the complete path. /dev/ where is VG name? Okay, and what is my LV name? Okay, so this is the complete path I'm giving, and say, and it is set up, it is done. Okay, now you have to activate it. You have to add into fstab file and activate it. So can you check like a cat that existing swap first? So grep a swap. Okay, so this swap was already created by someone, right? So we can make similar entry. Okay, let's vi cfs tab, where is swap, this one swap, right? So I'm saying double yy anc, and I'm adding just p for paste, the complete line I pasted in there in vi. Okay, and now VG name, our VG name is same, but the LV name was different. So this path is little bit different than the previous, but both are same. Okay, this path, and we create a swap on that is different, but both are pointing to the same. We had given this path, okay, and here we are mentioning slash dash slash, but both are same actually. If you can see here, this LV is created underneath this VG. So you can give that kind of notation, you know yeah, notation or name convention. So slash dash slash map up to this one is same, this up to this is a VG, and from here the LV name is starting. So I'm removing that. I'm pressing X. Then what was our LV name? Our swap LV name was this one, and this I pasted there, and this is also a swap, and everything is same. Here you can see it's a return swap at mount point column. It's not like the other file system, like for example this is a mount point because it contains a file system. For file system there is a mount point, but for the swap there is no mount point. But at the mount point it is mentioned as swap. Okay, so just save that. You can check that where with a cat that our file, and check our entry grep. What was our name? We created that swap, this one, right? Grep that. Grep means extract that string. So this is our entry in that file. Now after you added that entry in FS tab, you can activate that. For activating activate that swap, so you can say like swap on is the command, and A for activate. It will activate all the swap space, swap partition, or whatever swaps mentioned in this file. It will, everything will be activated by dash A, and say activated. And you can check like dash S what initially it was showing. Here you can see is only one partition, like one swap, this one. Now you can see there are like two. It's showing you this one, that the second we added like 1 gig. How this 1 gig is written, you can see here, like this is in K. So this in K, this many MBs, and this many 1048 MBs means 1 GB. Okay, and there's a priority, which has the most priority. The first the system will contact to this swap first, and then if that is full, then it will go to the next swap. This next swap is like as good as another memory now. If your system is full with so many some installation programs or something, and hundreds of users logged into the machine, and then memory is out of space, means like memory is full, then the system will use this partition you created for the swap. And this is the way you have to create a swap. Like it's like adding a more memory to the machine, and the thumb rule is make it like a the swap space, make it like a twice the size of your physical memory. Your physical memory means like RAM. If it is like a 4 gig RAM on your machine, make it at least make it double, at least make it a 4 gig swap, or maximum make it like 8 gig, make it twice. That is the thumb rule. So this is the third part. Like first we learned how to create a file system and mount, right? Then we learned that how to remove that LV or file system, right? Third one, no, the second we learned is how to extend that file system, then how to remove that file system or remove that LV, then right, and then we learned that swap, how to add more swap. In other language we can say more, add more memory, like make a disk use as a memory. Okay, that is swap. And that's all. These are the four things we learned. There are some commands to check what kind of file system I am running. If it's just a df minus k, it doesn't show what kind of file system on this. Okay, whereas if you run like a df minus k, then L capital T, right, it shows this is the file system, this type is this ext4 file system. Okay, you have to note down this. um, you know somebody may ask you how to display what kind of file system uh, the volume manager is LV is using, or LV contains what kind of file system. So this LV contains ext4, basically all contains ext4 except this one. This is actually swap, I think. So these are the things we learned. So today, for now, we are stopping here. This is end of file system session.